this episode, we are covering virtualization, which is one of those topics that sounds harder than it really is when you first hear the words. Many beginners think virtualization is only for data centers or advanced engineers, but A-plus learners need a plain understanding of it because these ideas show up in modern support, cloud services, testing, training, and business desktops. A technician may not build large virtual environments on day one, but they do need to recognize what a virtual machine, VM, is, what a hypervisor does, what a container is, and what desktop virtualization means when a user says their desktop is running somewhere else. The main goal here is not deep engineering detail. The main goal is to help you tell these ideas apart, understand where you are likely to see them, and understand what problem each one is trying to solve so the terms stop blending together and start making sense. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. A good starting point is to ask why virtualization exists at all. The simple answer is that people want to get more use out of hardware, keep systems separate from one another, test things safely, and make computing easier to manage. Without virtualization, one physical computer usually runs one main operating system, OS, and does one main job at a time. With virtualization, that same hardware can be divided, shared, or used in smarter ways so different environments can run side by side, without each one needing its own full computer. That matters in real support because businesses do not want to buy extra hardware for every small task, and they do not want every test or training job to happen on a live production machine. Virtualization gives them a way to separate work, reduce risk, use resources better, and recover more easily when something goes wrong. And those are all ideas a beginner technician can understand without needing to become a specialist. AVM is usually the first virtualization idea people meet, and it is also the easiest one to picture. AVM is a software-based computer that acts like a real computer even though it runs inside another system. It can have its own OS, its own settings, its own storage, and its own applications, and to the person using it, it often feels like a separate machine even though it is really sharing physical hardware with other systems. A technician should think of AVM as a full computer experience built on top of software. That is why AVM can be used to run a second OS on one computer, test software in a separate environment, or keep an older application working without changing the main machine. The key beginner idea is that AVM is not just one app or one isolated file. It is a full virtual computer with its own identity inside the larger physical system. That full computer idea matters because AVM needs the same kinds of core resources a real machine needs. It needs processing time, memory, storage space, and access to devices or networks in some managed way. The physical computer underneath provides those resources, and the virtualization layer decides how to divide them, so each VM gets what it needs. If the host computer is weak, then the VM will feel weak too, because it is still depending on the real hardware underneath. That is why technicians pay attention to how much random access memory, RAM, a system has, how much storage is available, and whether the processor supports virtualization features well enough for the job. A beginner does not need to memorize every platform setting here. What matters is understanding that a VM feels like a separate machine, but it is not free from hardware limits. It still depends on the real computer below it to provide enough resources for stable use. A hypervisor is the software layer that makes VM use possible. Its job is to create, run, and manage the virtual machines while controlling how they share the physical hardware. A beginner can think of the hypervisor as the traffic manager between the real computer and the virtual ones. It decides how processor time, memory, storage, and other system resources are presented to each VM so they can run as if they were separate computers. Some hypervisors run directly on hardware, which is common in larger business and server environments, while others run on top of a normal OS, which is common on lab machines, training systems, and personal computers used for testing. That difference is important because it helps explain where technicians are likely to see them. In a support lab or classroom, you may see a hypervisor running on someone's laptop. In a business server room, The hypervisor may be the main platform the hardware boots into before any VM ever starts. A hypervisor that runs directly on hardware is often used when performance, stability, and central control matter a lot. Businesses like this model for servers because it allows several VM systems to run on one physical machine in a controlled and efficient way. A hypervisor that runs on top of a normal OS is often easier for learning, testing, and small lab work because it fits into a regular desktop or laptop environment more simply. For A+ purposes, the main point is not memorizing which product belongs to which category. The main point is knowing that hypervisors can be closer to the hardware or more like an application layer on a normal computer. A technician is likely to see this difference when helping with a test lab, working with a training environment, or supporting a system where several VM systems live on one machine. Once you understand that the hypervisor is the manager, the rest of the VM idea becomes much easier to follow. Technicians are likely to see VM systems in several common situations. One is software testing, where someone wants to try a program without risking the main machine. Another is training, where students need practice systems that can be reset easily after mistakes. Another is compatibility, where an older OS or older application still needs to run even though the main computer has moved on to something newer. VM use also appears in business servers, where one physical server may host several different services in separate VM systems instead of buying a different server for every task. The reason all of these uses make sense is that VM systems give people separation and flexibility. If one VM has a problem, it does not automatically mean the others are broken too. That separation is not perfect magic, but it is extremely useful, and it is one of the biggest reasons virtualization became such a normal part of modern computing. Containers are often mentioned in the same breath as VM systems, but they are not the same thing, and that difference matters. A container is a more lightweight way to package and run software with the files, settings, and dependencies it needs. Instead of acting like a full separate computer with its own complete OS, a container usually shares more of the host environment and focuses on running an application or service in an isolated way. That makes containers faster to start and easier to move around for certain kinds of work. A beginner should picture a container as a neatly packed application space rather than as a full virtual computer. That simple idea helps a lot because many people hear the word virtualization and assume every isolated environment must be a VM. Containers still use isolation, but they are solving a different problem. They are usually about packaging and running software cleanly, not about pretending to be a whole separate personal computer. The easiest way to compare a VM and a container is to focus on size and purpose. A VM usually behaves like a whole computer because it includes much more of a complete system experience. A container is usually much smaller because it is focused on the application and what that application needs to run. That means a business might use a VM when it needs a full separate OS, strong separation, or a test system that behaves like another machine. The same business might use a container when it wants an application to run the same way in different places without rebuilding everything around it each time. For a beginner technician, the practical lesson is simple. If it feels like another whole computer, you are probably dealing with a VM. If it feels more like one app or service packaged in a clean, isolated bundle, you are probably dealing with a container. That simple distinction will carry you a long way in early support work. Technicians are more likely to hear about containers in modern app environments, development teams, and cloud-based services than on the average office desktop. Even so, A+ learners should still know the term because container ideas show up in support conversations, documentation, and newer platforms. A technician may not be the person building the containers, but they may still need to understand why an application is described that way or why it behaves differently from a VM-based service. Containers help solve a consistency problem. They make it easier for software to run the same way in different environments because the application is packaged with what it needs. That reduces the old problem where something works on one system but fails on another because the environments are different. For support, that means containers are often used to simplify app delivery and reduce mismatch, while VM systems are often used when a full machine-like environment is needed. Desktop virtualization is another important idea, and this one is easier to understand if you think about where the desktop actually lives. In a normal setup, the user's desktop apps, and files are running on the same physical machine sitting in front of them. In desktop virtualization, the desktop may actually be running somewhere else, often in a server or data center environment, while the user connects to it from a local device. To the user, it still feels like their desktop, but the main computing work is happening remotely. This can be useful when an organization wants better control, easier updates, more secure handling of company data, or the ability for users to reach the same work desktop from different devices. A beginner should understand that desktop virtualization is about moving the desktop experience away from the local machine. The screen, keyboard, and mouse may be local, but the main desktop session is being delivered from somewhere else. One common business form of this idea is virtual desktop infrastructure, VDI, where users connect to centrally managed desktop systems instead of relying only on the power and setup of their own physical computers. This model can make support easier in some ways because the desktops are managed in one place, updated in one place, and secured in one place. It can also make device replacement easier because the user's main work environment is not trapped inside one damaged laptop or old desktop at the office. For a technician, this means some user complaints that sound like local computer problems may actually relate to the remote desktop environment, the network connection, or the server side rather than the keyboard and screen device on the desk. That is why desktop virtualization matters in support. It changes where the real computer work is happening, and once that changes, the technician has to think differently about what is local and what is remote. It also helps to clear up a few common mistakes beginners make when they first learn these terms. One mistake is assuming that every virtual tool is a VM, which is not true because containers are different and desktop virtualization is different again. Another mistake is thinking virtualization means no real hardware is involved, when the truth is that all of these systems still depend on real hardware somewhere underneath. People also sometimes assume virtualization automatically makes everything safer, faster, or easier, but it really depends on how it is being used and what problem it is meant to solve. A VM gives separation and flexibility, but it still needs resources and management. A container can be efficient and portable, but it is not a full replacement for every VM use. Desktop virtualization can make support and control easier, but it also creates more dependence on network quality and remote infrastructure. These are not magic solutions. They are tools designed for specific kinds of needs. A good way for a beginner technician to keep the ideas straight is to ask a few simple questions. Does this behave like a whole separate computer with its own OS? If yes, it is probably a VM. Is this mainly a software package running in an isolated way without acting like a full separate desktop computer? If yes, it is probably a container. Is the user sitting at one device while their real work desktop is running somewhere else? If yes, that is desktop virtualization. Then ask what problem is being solved. A VM solves separation, testing, training, and full system flexibility. A container solves app packaging and consistency. Desktop virtualization solves centralized desktop delivery and control. Those questions will not make someone an expert overnight, but they are more than enough to help an A-plus learner understand the core ideas and avoid mixing all of the terms together during support work or exam study. By the end of this topic, virtualization should feel much more organized and much less intimidating. A VM is a full virtual computer. A hypervisor is the layer that manages those virtual computers. A container is a lighter isolated app environment, and desktop virtualization means the user's desktop is being delivered from somewhere else rather than living fully on the local device. Technicians see these ideas in labs, testing, training, server environments, cloud platforms, and business desktop support because each one solves a different problem in a practical way. The biggest win for a beginner is learning to stop treating these terms like one big blur. Once you can tell what kind of virtual setup you are looking at and what job it is meant to do, the topic becomes much easier to understand, much easier to explain, and much easier to support when it shows up in the real world.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.